Structure basicity, that is basic nature relationship of amines. Let us consider the primary amine or N H H, a pair of electrons. Now, as I already told you, when proton is there, it is electronated. That is, addition of electron takes place so that it gives R, H, H, H is joined. Here it becomes plus. So it means a pair of electron is donated to the hydrogen atom, that is the proton H plus, so that it becomes what? Or NH3 plus. Now let us compare this with ammonia. This is alkanamine, that is primary amine. The same is compared with ammonia. Let us have N. Instead of R, you have H, H, H. Now a pair of electron and proton. Now you can expect the same. So the electron transfer. So N, H, 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 and this becomes plus. Now let us compare the alkanamine with ammonia. It is because of the presence of electron releasing alkyl group. The electron is pushed here. Electron pair is pushed. It is facilitated further. Okay. Therefore, the donation is more appreciable here. And that is why alkanamines are, so this reaction is more natural. So it means the RNH2 is more basic than ammonia. So this question may arise. Why alkyl ammonia, alkyl amine is more basic than ammonia? In ammonia, there is no electron releasing group, but in alkyl amine, there is a electron releasing group all. So that pushes the electron pair, and that is why this kind of primary amine is more basic. So what do you call this effect? In fact, this is known as the plus I effect. So that is why alkyl amines are strong base than ammonia. And the basic nature of aliphatic amine should increase with the increase of number of alkyl group. So naturally what we expect, increase of number of alkyl group, increase the basic nature. So in that case we expect, that is R3N is greater than R2NH, that is greater than RNH2, because we know this is greater than ammonia. Of course, this is agreeable, but what about this? Here, the trend is not regular as we expected. Diagram is one concept. The trending is not as expected because we cannot judge the basicity, that is basic nature, based on this plus I effect only. There is one more effect called solvation effect, that is surrounding of water molecule or solvent molecule. Okay, take down. Solvation. Solvation means surrounding of solvent molecule. So, according to this, that is greater the size of the ion, greater the size of the ion, lesser will be the solvation. Therefore, the stability of ion is less. For example, in the case of ammonia, the size is smaller, and that is why solvation is bigger, so more stable. Okay, so R, N, H, H, and here H plus protonated. So here water molecule, here water molecule. So this is called solvation. This is with regard to primary. This is much greater than now N plus here R, and then you have H, then here water molecule, water molecule. This is greater than N, R, and here H and H2O. Actually, that is you can put O here, OH2, because it links with the oxygen of water molecule. So you can put like this, OH2, OH2. Okay. So it links with the hydrogen bond is developed with the oxygen of water molecule. Now you can compare this, which has more solvation. Primary is more solvation. So that is why primary ion is, primary amine is more basic. And in the case of a substituted one, in the case of substituted. For example, you have substituted ammonium cation. In the case of substituted ammonium cation, the order of a basic nature will be primary is greater than secondary is greater than tertiary. And when we compare with the aryl amine, aryl amine means what? That is aniline. Aniline. Now let us study C2H5 twice NH. So what do you call this one? Primary or secondary amine? Secondary amine is more basic than C2H5 NH2 in this case. And that is more basic than aniline. And in fact, let me introduce here ammonia. Then aniline. So here ammonia is more basic than aniline. This is because of the stability of aniline. For example, aniline can undergo resonance. C6H5 NH2 parallel electrons. Now, listen to me. A pi lone pair of electron is transferred here, so that pi electron can be transferred here, so that it becomes here double bond NH2, and it has lost one electron, so plus. And here it becomes minus. Okay. And again, this will come here, so this will go to the edge. So it becomes minus here, and then NH2 bond here. And again, this will come here, and this will go here. So this is called delocalization of pi electrons, and thereby resonance arises. Plus. And again, now you are able to get, so this will come here. Automatically, this is satisfied. NH2. And you know, these two are calculus forms. So the pi conjugation, that is alternative double bonds, are totally relocalized here. And that's why they are called calculus structures. Structure 1, 2, 3, 4, 5. So structure 1 and 5 are called calculiform. When the same aromatic compounds are substituted with OCH3, electron releasing group, methoxy group, alkyl group, it increase the basic strength. Whereas substituent like NO2 group, SO3, sulfonic acid group, COH group, X group, allo group, they decrease the basic strengths. So you should note on this. Now you may be asked, that is aniline, toluidine, which is more basic? Toluidine is more basic. Why? Because of the presence of methyl group. Are you will follow? Now, nitrobenzoic acid. In that case, because benzoic acid is decreasing type, so it reduces the strength. Hmm? COOH, acidic. Now let us discuss about acylation. Next reaction, acylation. For example, C2H5 NH2. What do you call it? Ethanamine. This ethanamine can react with acyl chloride, acid chloride, CH3, C double bond O, Cl. What do you call it? Ethanoyl chloride. That is called acid chloride, commercially acetyl chloride. Now, you know very well in carbonyl compound, there is a pi electron transfer towards oxygen. So there is a tendency for becoming plus here, carbonium ion, and a pair of electron will attack here, so that you are able to get C2H5 N, and you can bring this H here, NH, then you can put H here and connect it to C, and then this is O, and here an electron is transferred. Now CH3Cl. Now once again this Cl minus, it can be removed as minus, as Cl minus when it is protonated, and this, you got this plus, is it true? Because it has donated one plus. Now this can be released as H plus, and H plus and Cl minus can be removed, so that you are able to get C2H5, and this will come here once again and forms a bond, a pair of electron. So C2H5 N H, and then this will come here. So C double bond O CH3. Are you able to follow? So this is known as N-ethyl ethanamide. Why? Because CH3 COO NH2. Let me explain this. CH3 COOH ethanoic acid. Remove OH in place of that. introduce amine. So CH3CONH2. This is called ethanamide. Okay, acetamide, hypoethanamide. So CH3CONH2, ethanamide. In ethanamide, N ethyl group is present. So it should be called N-ethyl ethanamide. Are you able to follow? N-ethyl ethanamide. Okay. N-ethyl ethanamide. Now, can you prepare similarly diethyl ethanamide? Where we have to start? You can start from diethyl group. Can you do that? You can maintain the same, but instead of H, you can put C2H5 so that you are able to get N diethyl ethanamide. Okay, try. Same reaction. Okay, take C2H5, C, C2H5, and then actually N here, H. Now, so this is diethylamine or N-ethyl ethanamine. N-ethyl ethanamine. What about this? Is it a primary amine or secondary amine? Secondary amine. So now you have to put CH3, CO, Cl, acyl chloride. So what will happen? Pi electron transfer and this will attack here. So that you are able to get C2H5, N, put H here, C2H5 here, and attach to carbon atom, and here you have got CH3, then O minus, and put Cl. Now you have to remove HCl. How to remove HCl? That is as H plus. Okay, and this one as Cl minus, so that this will come here. Okay, as Cl minus. So HCl is removed. Now the remaining is C2H5, N, and this bond will come here, so that electron pair, and again here C2H5, then C, and put double bond O, and you got the CH3. That's all. So what do you call it? Ethanamide once again, but two ethyl groups are substituted. So this is ethanamide, N diethyl ethanamide. Are you able to follow? N dash diethyl ethanamide. Okay. Shall we try with aniline? Try aniline. இதெல்லாம் மேக்ஸ் மாதிரியே அப்படியே போட்டால் தான் உனக்கு வரும். C6H5 NH. Okay. Now NH2 actually. So aniline. And what is the compound to be? Shall we take instead of acetyl chloride, we can take acetic anhydride also, because in acetylation studies you can use two types of compounds. One is acetyl chloride, another is acetic anhydride also. What is acetic anhydride? Yeah, CH3COOH, another molecule of CH3COOH, and when water molecule is removed here, you are able to get CH3 CH3, CO, CO, O. So this can be written as CH3CO twice OH. So what do you call it? Acetic anhydride. Okay. What is that? Acetic anhydride. What is IUPAC name? Ethanoic anhydride. What do you call it? Ethanoic anhydride. Now we can make use of this ethanoic anhydride. So CH3, C double bond O, C double bond O, CH3. Okay. Now it forms, that is CH3, COOH is removed, and here C6H5, as usual, one H is removed here. So you have got the H, and then you have here the bond is broken here. So you have got only C double bond O and CH3. So what do you call this compound? And CH3COH is released here. What is that? Ethanamide, phenyl. So N-phenyl ethanamide. It is not methanamide, now ethanamide, because two carbon atoms are. Okay, write down. Then there is another